Okay, so hyperbolas, the equation looks a lot like a ellipse, only we have a minus sign in the middle. Because the minus sign in the middle, when I start talking about a squared and b squared being big or small, it might be slightly deceptive now. So what I want you to think about is the one that's negative is the small one. So the one that comes second is the small one because that one's the negative. All right, so it's either that or don't worry about what's small or what's big and just, whatever's underneath this makes that, how we were doing it in the ellipses. Whatever was underneath the x's, that's how far I went on the x's. Whatever's under the y's, that's how far I go on the y's. This is going to work the same way, except with hyperbolas, we're only going to have it go in like one direction. It might, oh, it's frozen. Sorry, guys. Can't see what I'm writing. It's only going to go in one direction. So it could open to the left and right, or it could open up and down. All right, those are like the two hyperbola possibilities. And then just like we had ellipses before, and they had foci on the inside of those curves, when I break it apart and I flip these the other direction to make the hyperbola, when it looks like this, the foci are still on the inside of the curves. But you might say they're kind of outside of the figure itself, because it's like on the outside of the figure, but that's because the figure opens out now. So it's still inside those little curves, okay? The HK is exactly the same. It's the center, but you got to be careful because in this situation, H is over here. It's second. Even though you write it first, it's the X part of the center. So just be careful about that. Some vocabulary word, transverse axis is the axis that has the only vertices. So with this like little hyperbola example right here, there would only be two vertices, and the transverse axis would be the one that has those two vertices at the end. The conjugate axis would be the other direction, but it doesn't have vertices at the end of it. Okay, I'm going to put some dots there, but they're not vertices. We don't write them down. The foci, to find the foci, it's still going to be our C value, but to find it, it's now a squared plus b squared instead of a squared minus b squared. So our equation turned to subtraction and our foci turned to addition. So the equation and the foci equation, they're like opposite signs. The asymptotes, we're going to have asymptotes, which I'll show you in a moment. The asymptotes will be lines. To find the lines, if you can't look at the graph to figure out the equation of the lines, remember you can use the point slope formula, but we will write it in slope intercept form. And there will be two asymptotes. So I'll go through all this information doing a few examples. So the first example, is this in the correct form? It is not, because it should equal 1, just like the ellipse. So we'll divide by 36, and we'll get x squared over 9 minus y squared over 4 equals 1. So our center will be at 0, 0. So now there's only one set of vertices, and it's whatever comes first. Our x's come first. So we still do the plus minus. We do it with the 9, or square root of 9. Sorry, plus minus 3. It's the x's, so I'm going to apply that to the x part of the center. I'm going to put my numbers from least to greatest. And I'm going to graph those. So those are the vertices with the center. I am going to find the other points that are the end of the conjugate axis. Conjugate axis endpoints. But they're not called vertices. I'm going to find those, though, and you'll see why next. So those would be plus minus 2 to the y's. Now, they're not points. I kind of made like a little dash instead, just so I could see where it is going to be. I changed the color so it's not really part of the graph. And what I do next after I find those endpoints is I'm going to make a rectangle. And that rectangle is going to be the very ends of the transverse and the conjugate axes. Then I'm going to use a straight edge with, if you're using your computer, you can use the line under the shapes, but I'm going to write down what I'm doing first. Make 2 lines, which are going to be my asymptotes. That connect the center with the corners of the rectangle. So since I'm using the computer, I will just use my line tool. And I'm making a line, so to make it easier on myself, I think I'm going to figure out the slope. If I start at the center and I go up 2 over 3, up 2 over 3, up 2 over 3, that's the slope of that line. So I'm going to make sure it goes through those opposite corners. And then the other direction, it's going to be down 2 over 3. So I just make it a little bit easier to draw those lines if I knew what the slopes were. So those are the asymptotes that I just drew. I'm going to find my foci next by doing a squared plus b squared equals c squared. So I'll do 9 plus 4, and that's 13. So c is the square root 13, which is about 3.6. And the foci go in the same direction as the vertices. So those are going to be added to the center on the, for this one, for the x's. So I will have negative square root 13, 0, and positive square root 13, 0. And then it's about 3.6. So I'm going to start at the center and go out 3.6 to get that graphed. And then the last thing we're going to do is use our vertices and the asymptotes to just guide our drawing of the hyperbola. So I'm going to start at the one of the vertices and just make a hyperbola that gets closer to those asymptotes. And then the last question is asking us to write down the equation of the asymptotes, which this one's pretty easy to look at and figure out. So I'm not going to use the point slope form for this one. I already said the slope out loud when I was graphing them. The slope, one of them's positive 2/3, the other one's negative 2/3. And what's the y-intercept for those asymptotes? 0. So my equations will be y equals negative 2/3 x and y equals positive 2/3 x. So it's pretty similar to the stuff we did, with the exception of now we have asymptotes. All right, question B. Write down your center. And then check it with mine. Did you get tricked? Did you? It tricks me all the time. I have to think about it. Okay, so make sure that the X is the one with the H that comes first, and then the K is next. So now that Y comes first for this one, even though the number 9 looks smaller than 16, just keep in mind 16 has the negative. So 9 really is the bigger number. So 9 is the one. The Y's are the ones that have the vertices for this one. So we're going to plus minus 3 to the Y values, and those are going to be our vertices. All right, and then I'm going to find the other points, which are plus minus 4. And you can write them down if you want. You don't need to. I'm just going to go out 4 from the center and make that rectangle. So if I'm using this rectangle, I'm going to go up 3 over 4 or down 3 over 4. Make sure I cross through those corners. And the foci is a squared plus b squared equals c squared. So I'm going to add the 9 and the 16 together, which is 25. So c is 5. And that's going to add to the same number that the vertices were added to, the y value. So -1, -3, -1, 7. And then you, oops, sorry, at the wrong place on the bottom one. And then you're gonna draw your hyperbola arms so they're getting closer to the asymptote. And they're rounded. Okay, for this one, I'm looking at those yellow lines that I drew, and it doesn't look like it hits exactly at a nice integer. So I will use point slope form for the asymptotes this time. So point slope form is y minus y1 equals m times x minus x1. I already know my m because I was counting as I drew those. One of them's 3/4. The other one's -3/4. Right? Is that correct? Yeah. And then I just use the center because that goes through. I just use the center for both of them. That one's easy. So we'll do y minus 2, and I'll have x plus 1. So it's really like the same equation for both, except one's the negative and one's the positive slope. So I get a y-intercept of 5/4 and 11/4. And if I go and I just, double check on my graph, does that seem reasonable? 5/4. So that would be 1 1/4. Yeah, that looks about right. And then 11/4 would be like 2 3/4. Yeah, that looks about right. So I probably did it right. If it doesn't look right, maybe check your work. Any questions so far? No, you're just enjoying every second of it? Okay. How about when it looks like this? Got to complete the square first. Completing the square is almost identical to what it was before. So we're going to rearrange 25x squared minus 50x plus some square minus 4y squared plus 24y plus a square. I'm going to move the 111 to the other side and add those squares. If there's a number in front of the x squared, you have to factor it out. Okay, so here's one place some people make mistakes. You're going to factor out this -4 out of a positive 24. So just make sure that you change that sign on the y. Because if you don't change that sign, you're going to have your center wrong. And if your center's wrong, a lot of stuff's going to be wrong. So I'm going to plug in 1 for the first, complete the square, multiply that by 25 to the other side. The second one, I'm going to plug in 9, but what's going to go on the other side? -36. Good. -36. So we'll have 25 times x minus 1 squared minus 4 times y minus 3 squared equals, and I'm pretty sure it's 100. Yeah, so divide everything by 100. And we get our equation. Once you take a moment and see if you can graph this one without my help, I am in a moment going to just do it up here. So if you get stuck, you can just look up here. But I'll give you a moment to get started without my help. See if you have a question. If you need to leave, feel free. I did not get to go over writing the equation with the given information, but that should be just like the ellipse stuff, just different equation. Maybe I'll stay and do another example on here just so it's in the notes. Okay. If you guys are still listening, that's cool. If not, that's cool as well. I'm just going to do this for the notes. I mean, for you, but for the notes. Juan? Yeah, I can stay here for a moment. So that last section, you're just given information, just like we were with the ellipses. Here, if we've got the vertices at negative 10, 3 and at 10, 3, the center is going to be the midpoint of those. So the center would be at 0, 3. So negative 10, 3, 10, 3, and then 0, 3, I can already tell that X is going to come first. And the foci would be at negative 12 and 12. So the C value is 2. So C squared is 4. Oh, I forgot to do A squared. So A is 10. So A squared is 100. A squared plus B squared. Nope, that can't be right. It's not 4. It's 12. So 144. So 100 plus 44. So that means this has to be 44 here. So it's the same problem solving that we were doing on ellipses. And that one's pretty much exactly the same. And then this one talks about the length of the conjugate axis. The conjugate axis is not vertices. And the length is 8, but that means the B value would be half of that. So then the b squared would be 16 for that one. And I'm just not going to finish these because we had lots of practice with those already. And your assignment is on the module.